expert for the energy track. Am I right?
No, for the machine economy track.
Machine economy track, excuse me. Do tell, what's your expertise?
I have been providing some examples from biomimicry to the teams because...
Hang on, biomimicry.
Yes, biomimicry is learning from nature. So bio is life or nature, and mimicry is mimicking or learning from. And the whole track, the machine economy track, is based on, or the underlying thought is, can you create a machine-to-machine economy, a machine-to-machine ecosystem that, resembles natural ecosystems, or what can you learn from natural ecosystems? Because a lot of what we're doing right now in our human ecosystem is obviously not working because we're creating a lot of waste, there's a lot of inequality, there's a lot of problems, and if we're going to take this one step further into a machine ecosystem, what can we learn from nature?
Okay, so can you give me one example of one of the things that you helped the teams with?
I have been giving a few examples of swarm behavior and how you can base algorithms of swarm behavior.
And swarm behavior is
for example,
an emergent type of behavior, right?
Yes, it is an emergent type of behavior.
So that means that by knowing one identity in the swarm, you cannot really predict what the swarm as a whole is going to do, or can you?
You're definitely on the right track. When we look at a school of fish or a big flock of birds, we sometimes think that the way that they're moving, that there's a mastermind behind it, that there's a purpose behind it. But quite often,
that they had a meeting beforehand,
yes.
and okay. So
it's just quite a simple set of rules, quite a simple algorithm behind it that just dictates every individual behavior. But as a whole, they move as a group in a way that looks a lot more complex.
Mm-hmm.
Do you want a few examples?
Yes, please.
Okay. Locusts, grasshoppers, they can move in really big groups, sometimes I think maybe even millions of them, and they don't collide. They do this by taking in a lot of information around them, but their brain only pays attention to the information of other grasshoppers that it's about to collide with. So it only really sees the things that is in front of it, that's moving towards them or moving into their way. So their brain doesn't really process the information of grasshoppers in front of them that's moving away, or other ones around it.
Right, so it filters out a lot of all the other information.
Yes,
so how does this apply to a machine-to-machine economy then?
Well, if you would have a machine economy with a lot of machines, maybe there are drones or there are other kinds of robots, and you want to kind of program how they would interact, you want to steer their behavior. You could do that by having some kind of mastermind, and that would take a lot of energy probably to calculate this and try to optimize it. Or you give every single machine a simple set of rules. And that was just one example. In nature you have several different examples of several different kinds of rules of interaction, but it gives it low energy algorithms that's easy for a small machine to compute.
So one of the quotes from, I think it is Albert Einstein, is we should make things simpler, but not simpler than that. So if you're talking about simple rules that help a swarm of robots do their stuff, how do you know that your set of rules is simple enough but not too basic?
Difficult question. I'm not a programmer or a tech person myself, so I provide them with a few different examples of this is how you could learn from it, and I'm guessing that they'll try it out and see what works. Okay,
so but if you try to mimic nature, then how do you make sense? How do you find out that the grasshopper filters out that information? That is one way of finding out what your minimum set of rules is, I guess.
Yes. To mimic nature, you could watch a lot of National Geographic.
Okay, that's one.
Or just go online, and there are websites where you can that gives you examples from nature, where you can actually say, hey, I want to find examples about cooperation, or about algorithms, or about processing certain things, and they'll give you short examples of with scientific references of how these animals do it.
So,
or not just animals, trees, plants, whatever.
So to close the interview, You've been helping the teams out. Are they very receptive to the experience and the expertise that you bring?
I think so, yes.
Okay.
Because, well, this was just a very short thing. We've been talking about ecosystems as a whole as well, and what guides an ecosystem as a whole, and I hope that they can take out the little parts that are important to them when they're thinking about their machine ecosystem.
Because it is both about the bigger picture and the individual thing.
Definitely.
All right. Well, thank you very much for taking the time to being here, and
thank you for having me.
Enjoy the rest of the hackathon.
Thank you.
Thank you.